How you guys doing? So today I'm going to go through a video on primarily the use of AI generated images in a visual effects pipeline. This video will be more catered towards people in that industry, in that background, but also people just jumping into AI generated imagery. We'll probably at least get some insight on how to better control the elements in the image, and also just some of the work involved on the visual effects side and 3D tools and 2D compositing tools. So my intention with this video is probably going to be a multi-part thing where I'll go through the entire steps of producing a finalized shot, a visual effects shot using AI generated diffusion models. This will be like a precursor to a lot of the more things that happen on the AI side. And so what I'll do is I'll jump into 3D and kind of like the basis of like how this thing was created, how it was rigged and modeled, and how the scene was set up and layout and all that stuff, the passes, some intermediate steps in compositing, not really compositing in a sense of how it is done in the visual effects environment, but more intermediate step from getting elements from 3D that are more aligned for use with AI generated content and get those into a tool such as ComfyUI, which is using lower bit depth images of 8-bit. So the workflows I'm going through are mostly helping with art direction. Currently, like if you're trying to do this stuff with just text prompts, you're never going to be able to describe, for instance, something like this kind of robot thing crushing all these cars and stuff. So you really need to rely on external elements to go into the graph and use that as a way of driving everything. So I'm not going to cover animation yet because, well, frankly, there's no workflow that exists right now to be able to do that. But I feel like in a bit of time, a couple months, probably less than a year, we're probably going to be able to see models that can handle that. And what I'll do is come back to this whole scene and work on it again. Right now I have the start of a workflow for animation, but it's not working yet. And I'll show a bit of the details of that later in the video. So let's jump into Maya and 3D and start from the beginning. So inside of Maya, here's the scene. So we have a Hexapod robot, and it is walking along these cars. So if we go through the camera, here's the camera. This is what gets rendered. Let's press play. And there's our shot. So this is 120 frames and a little bit of camera shake, and yeah. The actual robot here is actually quite interesting how it's rigged up. So I'll actually jump into that and kind of show you how all this stuff has been set up. So I had to 3D model and rig this spider. The 3D modeling was done effectively by kit bashing. So I have a number of these advanced looking technology kind of kits, and then that was a combination of kit bashing a bunch of that stuff with some NURB surfaces. So like these smooth looking things. Same with the back here. That was all just NURB surfaces, and then yeah, combining all that stuff into polygon geometry, and then finally I threw it all into ZBrush and I just basically combined everything and then decimated the results. So as you can see here, like if I go inside and let me turn on two-sided lighting, you'll see that the inside of this thing is it's not like a ton of intersected geometry. And this just saves a lot on the poly count. So I went from pretty much a 10 to 20x reduction in polygon geometry. And that just keeps everything nice and fast in real time. So for the Hexapod rig, the legs, I did the legs in their own scene. And then that way I could reference them in to the Hexapod body. And then that way, if I make any changes to the leg rig, I don't have to do it multiple times. The IK setup for a single leg, it's not trivial because the main problem is each of these joints has to move in one axis. in order for it to work. So the main things to get that working was this joint here. It's effectively constrained to this ball right here, right there, and it's kind of pointing towards there. And that ball is also the pull vector for the IK system, and then that thing is kind of moving along. This is not like a perfect solution, because if I do go above, it does flip. The Hexapod rig itself is fairly straightforward, except for the way the body moves. So you'll notice that when I move the legs, the body not only translates but also rotates, and you get some interesting complicated movements by just moving the legs around. So you don't necessarily have to animate the body so much, but yeah, you can. And yeah, this is a good example of like how the legs work, all the little individual IKs, all the joints and how they're constrained and stuff. And yeah, and then all the extra motion you get by one of these legs. On the body control, I have a parent group here, and you'll see here that I have in purple on the rotations, I have expression driving that, and then in blue I have a point constraint. The point constraint is driving that group by point constraints on these controls. So you can see here, it's all weighted between them all, so that way as I move them around, it's gonna like average the position of all those points. The expression in the expression editor, right there, this is basically just doing linear regression, and it's taking all of those controls right there, and the location here is, you need like an origin for this whole thing to work, or else it's gonna have this like swimming effect through. It's not gonna look right. And then yeah. So taking all those points go into an array, vector array, and yeah, and then here we have the loop. So this is just adding a bunch of this stuff up, and then here's the actual linear regression formula, and then this is the output back to those two channels on the rotations. So I am by no means an animator. I've rigged hundreds of assets for films, and I think I've only had to animate one or two maybe assets in a film. But so here's my take on how I came up with the animation for this thing. So the scene only has one asset to be animated, which is the spider, and that's what the animation looks like. 120 frames. So the way this works, what I found, so this is a specific walking gait for a hexapod called a 12-step, I believe it's called a ripple, 12-step ripple, and that can be done by first making a tripod gait, which is 3 legs pick up at the same time, and then they go down, and then the opposite 3 legs go up. And then what you can do to move the tripod, which is a very simple looking gait, to something that looks more organic like this, is to offset the leg animations. So the legs in the first leg of the 3, that one you shift all the animation forward a bunch, and then the last leg you shift it backwards, and then that way you're offsetting those 3 legs of when they actuate, and that gives you this kind of motion. Other than that, to add some weight to make it look like it's kind of heavy, some things on the animation curves themselves. So here's the animation for a given leg, and on the Z, which is the most important, it starts off flat, so it kind of ramps up its motion because it's heavy and it's, it can't move instantly, and then when it hits the ground, it's going rapidly and it just kind of stops. And the center point, it was all shifted from the center and then weighted over to the end, because it should take longer to lift itself than going back down. Like going back down, it's going to be going with gravity, and that gives you this nice motion where like it lifts up quickly and then it falls down, or it lifts up slowly and then it falls down quickly to give it more of a more organic kind of look to it. After figuring out the walking gait, I just pretty much just offset all the legs so they're actually touching something onto the ground, whether it be the ground itself or one of the cars. I was thinking of trying to incorporate animating the cars themselves, so when the leg hits it, it would like press down on the car. But I decided not to do that, keep it simple, and see if I can get the AI generated video to do that, which I wasn't able to. The whole point I wanted to do was to make as simple a scene as possible to convey what I wanted. So effectively like a previs animation, and then that way try and get the AI system to see if it could do, you know, the hard part. So what that meant really was basically just work with geometry and no texture in anything, no dynamics, none of that stuff. The lighting was kept basically really simple, just like a overcast day, just like an ambient occlusion kind of look to everything. What I found out was I don't even really need to render a beauty paths, because with this stuff, the sketch paths, which is like a toon shader, and the Z depth is pretty much all you really need to give the AI diffusion model something to work with. So on the lighting side, I got a number of passes. The primary ones are your beauty, your mattes, and toon shader. And let's just see what that looks like. So so one of the things you want for the system is you want all the edges of things. So I use a toon shader, and that gives me this kind of look. The silhouettes are a little brighter than the details. Move in a bit. Something like that. So you see like all the little kind of details. I wanted them to be a part of this stuff to have an effect, but I wanted them to be a lesser effect. I wanted like the silhouettes of objects to be the most important factors, because like if that's a car, I want that car to be a car and not kind of something else. So on the color side, if we go over here and we render that, it's basically gray shaded and it's got a skybox, so it's kind of like an overcast day, and that gives you all those kind of details. And that's how that looks. And then the last one was, and also on this color pass I have AOVs, so I need to have Z depth, obviously, so I render that AOV on that mask, on that pass. And then to isolate objects, so I have the city in blue, some cars in green, and then the robot in red, and that gives me that. What I found come on, Maya. So Maya crashing, as we all know, happens, and so far, at least I found with my super limited use of Arnold, is it's very buggy and crashes all the time. And what I think is probably a better solution is to, instead of rendering stuff like I'm doing out of Maya with Arnold or another renderer, bring all this stuff into Unreal Engine and do your layout there, and then add in like photorealistic assets from their free asset store and kind of build it up that way. That way you can get something that looks a little better than a gray shaded model, and then you can have more art direction that way. Like if you need a puddle to be here, or a bunch of debris or a tree in the background or whatever, that's far easier to do in Unreal Engine than it is to do in something like Maya. Not only that, but rendering in Unreal Engine is real time or near real time, and in something like Maya and Arnold, you're looking at like 10 minutes, a half an hour to do the same thing. And this whole system does have a lot of computations on the AI side, and I think it's better to be spending more time on that side, letting it do that stuff, than spending time rendering elements to get to that side. So before you can get to ComfyUI and do all that fun stuff, you have to convert all your EXRs into something else like PNGs or MP4s. ComfyUI, it only reads 8-bit images or video, and yeah, so you got to convert your EXRs. So stuff like Z-depth, unfortunately, you can't bring in Z-depth correctly with like actual values of pixel depth. You have to compress all that stuff into an sRGB image. And so for instance on here. So what I'm doing is bringing in, and also another thing on the Z depth for ComfyUI, closer objects need to be white, and then further objects needs to be, darker off in the distance. So you have to invert it that way. So converting the EXR down to sRGB, I use a grade node, and then I adjust the black and white points and the gamma to get it into like the range of an sRGB. And I'm sure there's a better way. If you're a new compositor, tell me what's the best way to do this, because as you see, I'm not even in Nuke. I'm in Natron. But yeah, so like the main thing I found with trying to get good Z depth into ComfyUI is it really depends on what object you're going for. So for instance, you see that I clipped the blackest point is like at the distance of just past this car. If I had the black point to be like way down in the distance, so like if I add another 0 here, down there, and I haven't even reached the end of this street, you'll notice that the robot is completely whited out, and in sRGB there's basically no detail there. So and I know that when I'm working on this robot, I want like accurate depths of all that geometry, so I brought it in more. And you'll find that depending on what asset or element you're working on, comping in ComfyUI, you'll want to have different depths, Z depths for those things that are particular to those objects. Initially when I started out, I produced image sequences of PNG files, and I read them in that way. But I think the better way is to use video files with ComfyUI. I think it'll save on space, memory space, and I think it's just an easier way to work that way. And the best way I found to get in that way is to use H.265 high efficiency and lossless. So if I go to the advanced, see lossless. But the main thing is to change to RGB, and that way, like if you're doing a single unpacked image like this one, it's not as important. But if I'm packing in, for instance, the edge with Z, so like if this is on channel R, and then I had like lighting or something else on G, and then the depth on my last channel, and I did it all together. If I don't encode in RGB, they're gonna like if I'm gonna use like YUV, they're gonna bleed into each other, and then you're gonna have issues where like the color is gonna show edges, like the edges are gonna bleed into color and all that. So you just want to be cognizant of what you're writing out. And the good thing is like when you're doing it lossless this way, these files are not very big. They're like 50 megabytes or less, and it's not like you can do throw in like a 2K or 4K image into ComfyUI and be able to do anything with it, because it's just too high resolution. These images, as you see here, it's like 720p kind of resolution. So here's an example of one of those high efficiency MP4s brought back in. So the RGB, all nice and multicolored, but then on the R channel, on red, we got the edges. Green, we got lighting, and then blue, we got the depth. And you'll notice that none of them bleed into each other, which is very, very important. So definitely use RGB when you're encoding this stuff. So finally, inside of ComfyUI, and ComfyUI is where all the magic happens. And what ComfyUI is a open source tool that is node based, and it's designed for working with AI based diffusion models particularly. Generally what you're doing is you're bringing in pixel images, and then you're working with latent space images. And a latent image, from my understanding, you can think of it as if the diffusion model that we're running is an encyclopedia, then a latent image is like a description of the image. Like if you heard of like the term like a picture is worth 1,000 words, it's kind of the same idea. So with enough descriptors of an image in latent space, you can then describe what it's going to look like through the eyes of one of these AI diffusion models. So this is the workflow that I've so far found success with, and I don't think it's the most optimized. I think there's ways to improve this, but I'll go through the steps involved. So first, over here, you bring in your source media. In this case, I'm bringing in video files, and because I only want to work on one frame of this sequence, I'm setting my load cap to be 1. If I set the load cap to 0 or a specified amount like 16 frames, it's going to batch process 16 images at the same time through this whole network. And if you're just working with like a single image, you could just be running in loading in a PNG file that represents these same files. But yeah, it depends on what you're doing. So the way I found going through this, and let's just look over here. So this is the CG render that goes in. This is the RGB color pass. First step is to build a base that I find with prompts. So we can go over here. So some of these prompts in brackets like this. In ComfyUI, let's say I want to emphasize that it's an overcast day, or overcast. I can emphasize this or de-emphasize it by using Control and bringing it up and down, and that'll emphasize that it's overcast or not. So if I wanted it, if I knew that it was going to be wet out and I want more puddles, I would just add wet, and that would, bring in more puddles on the ground. You can actually see that. So if I run this, so here it is right now, going through the K-sampler. And so this is the original image, not wet, and then you can see here how it's building up a wet image of that, and now we have wet ground. And the next layer, so I'm doing it in different passes. So this section right here is doing nothing but the robot. I have the mask over here. I'm taking the mask of red, and I'm masking out the latent image that way and working on it here. And then this final one down here, I'm increasing the resolution of everything. And you'll notice over here, so notice I added the word wet, and this is just finishing up, and we can see down here it's adding in, it's making the whole scene more wet, puddles and stuff. It's adding more atmosphere in the distance too. Once it's decoding the image, there we go. So from dry to wet. Like if you had to do this in CG on a still image, this would be a ton of work, but this was like 1 minute or so in with AI, which is really cool. Some things, let's see here. So this image here, this was the original image from CG, and this one is double the size. And the way you up-res images in ComfyUI is, well, there's a number of ways. The best way I found in terms of the context of what I'm doing here is first upscaling the image using like a super resolution model. So this model here is called 4x Ultra Sharp, and what this will do is it'll take an input image and it'll make it 4 times bigger by up-resing that image to 4 times. So if it's like a 1K image, it's now going to be a 4K image. And you don't want to rely on this on your own. It'll give pretty good results, but you can always do better. In the example here, what I wanted to do is up-res 2 times, and I don't have a 2 times up-res model. So what I do is I up-res it 4 times, and then I drop it back by 50% to give me 2 times. And then over here, I'm going to resample it to then produce the final image. This image here and this image here, you'll notice that they're not the same. They're similar, but they're not the same. Like if you notice this car side is facing us over here. Now that car is kind of rotated, and also now there's a car the same color as the robot down there, and there wasn't over here. Many things in the image change, and the reason why that happens is the denoise factor. So if I had this denoise set to 0, it's not going to do anything. But if I had this noise set to 1, it's going to forget everything that came in, and it's going to try and make a completely new image. But depending on where you have it in the middle, if you're not really caring so much about changing the image, but you want it to look similar, but very sharp and high resolution, 50% works well. If you're more concerned about features in an image, like let's say this car, for instance, you want this car, and you'll notice it's not the greatest looking car quality wise. You want that car, you can keep that car in its same orientation by dropping this noise factor down to something like 3.5 or 0.3 to 0.3.5, and then that car will be there. So if I put in 0.3 and run this, the image is going to be more similar to this image, but it'll have a little bit less detail in terms of sharpness to things. See that once it finishes. So there it is. So this new image here, now the car is facing us. We still got a new car there. Maybe that was a car in latent space, not sure, but it's came out looking like that now. Yeah, so that's something to think about, but some things don't look as great. Like you'll see the background, it's kind of more sketchy looking, whereas if I dropped it back to 0.5, I think it gave a more natural looking result. A lot of nodes for this, for instance, like this case sampler, bringing stuff in, they look like this. This is some basic stuff about ComfyUI. If you want to control stuff like steps that are parameters here, you can drop them as change them to inputs, and then you can drive them that way. So you'll notice here that I have a bunch of input values that I'm driving all of these case samplers at. Yeah, and you'll see like 50%, it's now cleaner looking in the background, more photorealistic. Some things that I think could be improved on this that I'm trying to figure out still, but I haven't yet, is right now I have a bunch of masks. I have the robot, the cars and stuff. If I had a scene where I wanted a high amount of direction of the art, the way it looks, I might have a whole bunch of these things. I might have like 9, 12 masks, and I might want to be controlling everything. Like I might want to control just this car here, maybe just parts of the robot. Like I just want to control the color of those things. Maybe this wall here. Maybe I need to have a billboard there, and I need to control the text of what is showing up there. You can do all that stuff through masks, but I think what you could do as an improvement, I haven't figured this out, but right now I'm doing them one at a time and running a case sampler as a base, and then I'm building up one case sampler per element that I want to run. But I think you can chain them all together as conditioning and run like lots of conditions for different elements in an image and run one case sampler for that. So like you could go from a base image such as this to an image with all the descriptors that you need to control, and then do your funnel up resolution. You can control like these conditioning nodes. There's stuff like conditioning concatenation. I think this could probably do it, but I haven't been able to get it to work. And that is basically taking the descriptors of like these prompts with your control nodes, your control nets, and describing that. I think you can tie it all together that way. Let me know if you know how to do it. I'd really like to know. In terms of controlling the image, that is mostly done, I found, through your Z-depth and your edges. And this is happening through what are called control net models, and they're over here. This one here is Z-depth, and I'm taking in the image here. It's really noodly. It's hard to see what everything is, but I'm taking this image over here, this video, and running through here with a strength of 1 and a start and end percentage 0 and 1. And over here, this is the edges coming in, and I have the strength a little bit less. I find that Z-depth is something, it's always good, I find, to have it really high, especially with something that it doesn't really know what it is. Like, I know this model has never seen like a robot kind of thing like this before, so it's going to try and come up with something different all the time, and you really have to constrain it down using control nets to exactly what you want it to do. The way you go about actually art directing what you want something to look like is through the prompts. So you generally are going to be working with a predominantly positive, and then you're always going to want a negative, but I find you're always working with the positive prompt. You generally, if you're trying to do something that's photoreal, you generally want to put in negative prompts for things that are like drawings or cartoon or anime. You can probably add quite a lot more. But yeah, most of the stuff you're working with the prompts here. And so let's say I want to change this image a bit. Let's get rid of Boston Dynamics. Let's put Terminator robot, like the Terminator, from cinematic frame from the movie Terminator robot, and let's change it down here as well. So we'll get rid of Boston Dynamics Terminator, and we'll make it blue. Let's get rid of spot as well, and we'll run through this image and see how much it's changed. So the base image is going to be from the movie Terminator, so it should look vastly different. The road, this is like very much like the road, like it's post-apocalyptic thing. So now the model knows what kind of the Terminator kind of looks are. You'll notice like the robot now, it looks like something from like a T-1000. Over here so over here we have the Terminator, blue Terminator. Now we got over here, so different look to everything. And then down here, over here, I don't have a prompt. What I'm doing is concatenating both of these prompts together and using that. So we'll let this finish out. The overall shape of things doesn't really change a whole lot, and that is due to the fact that the Z-depth is really restricting what can change on the object. But like minor things change. But like if I drop the Z-depth down from 1 to let's say 0.7, and which one is this one? Let's drop both of these ones down as well. Okay, good enough. Let me cancel this. Let's get rid of that, and let's change it to a sunny day and see how much that affects the image. So right off the bat, you'll notice we don't have overcast diffuse lighting anymore. It's now trying to throw in some, sunny contrasting. Also, we got a sky. We got sky and clouds. Sunny, cloudy-ish day. And you'll notice also the robot, because we dropped the Z depth and edge control weighting down, the look of everything is less round, or at least on that one. Over here it's similar. And everything about the image, like the cars and stuff, that all is very the same. The look of that kind of stuff is mostly determined by the seed. But yeah, let's play around with the seed and see what happens with that. So the base image here, if I change it by 27 to 28, it's going to change a lot of the look of these things. So basically the seed is changing the noise coming in, and the noise represents 80% of what the image is. So you see how much that changed? I'll cancel it and do it again. So again, everything kind of changes. The weird thing is like the lighting is not accurate to this robot. Also notice that one just made a cool little wall right there. Like the robot shadow, it's not real. A lot of details in the image I find with this, they don't make a lot of sense, but they're plausible. Let's not make it blue anymore. Actually, if we make it a gray, Terminator robots are gray, right? This case sampler, the denoise is set to 1. So what that means is the robot here, it's not taking any information from the one over here. It's completely changing. And then when it samples up, I'm taking denoise of 0.5, so it's basically just up-resing this thing. So there it is. That's pretty much all I have to say so far with this. As you can see, like to do a lot of these changes in these images, like if you're doing it conventionally with visual effects with like 3D renders and compositing, to make that big of a change with this image, it would take an enormous amount of work. Like every single department down to modeling, like modeling, rigging, all of that stuff. The lighting department, rendering, compositing probably is going to have to change a little bit, not so much, but like so much of the image, so much of the work changes in a whole pipeline. Whereas if you're generating still images like this, like it's 30 seconds on a GPU, which is pretty crazy. You'll notice this one, which is interesting, because I'm making a Terminator robot. Like the models, they're trained on so many images, and like it knows the Terminator movie. So what did it do? It stuck a Terminator in there. So that's pretty cool. If I make the robot instead of a Terminator, like from Transformers. Let's go. From Transformers. Let's try that out. Yeah, so changing quite a lot. It's adding a lot of different features. So like it knows what the Transformers movie looks like, and it's probably going to add like Transformers hands and weird stuff like that in the image, which is pretty cool. But yeah, I've been working on how to go from these still images to video, and unfortunately I've had no success with that. I have a different model down here that I've been trying to do experiments with to get from this quality to like a sequence that is like temporally consistent with no like jumping and stuff, and so far I've had no success with that. The main things I'm running into, let me control B is what you want to do to enable and disable nodes. The main issue I'm having is when you're doing video, it's really difficult, I found, to encode motion. So like this camera, this is only 16 frames, I think. Yeah, 16 frames. With the experiments I'm doing, I found that like, yeah, it's near impossible to encode a proper camera motion with this. I think eventually we're probably going to see some changes to this stuff to be able to encode motion, because going from something like this to moving with, like for instance, if I rendered out a image with motion vectors for every pixel in a sequence, which is very easy to do in 3D software, I could encode not only the camera but the like every single asset and every single thing in CG. Encoded motion could be done, and with latent consistency, we could get like final shots through AI like this, which would be pretty incredible. But so far, it's not a thing right now. But overall, like if you're doing concept work, this is a really good way to do it, because you could set up a system through Maya or whatever software and use Nuke and automate the entire process of generating these images, so you're spending like absolutely zero time in that and running in and like you could have a 3D model like this and then tumble it and see how it looks from a different side and render that out, and it would, yeah, it's very cool. And the ability to just quickly change like humongous, like having a big impact on the image by just changing a prompt is a really nice thing. Like going from an overcast wet day to a sunny dry day and having sharp shadows on the ground like that through like not having to re-render anything is pretty cool. If you're interested in doing this stuff, some further things for you to look at with this is IP adapter. I have one down here somewhere. Right here. So a lot of the stuff you'll want to look up how to actually use them, but the gist of it, IP adapter will take an image, the look of something like this, and then apply it to your source. And what it's doing is it's changing the model going in and producing a new model which has these kind of image effects on it, or the look of it. The look of this stuff, there's many models out there. The model that I'm using is Juggernaut, SDXL Juggernaut. SDXL is stable diffusion, and a lot of these are diffusion models. Stable diffusion model XL is a particular one that's been trained at a 1K square. The previous one, SD 1.5, that was trained on 512 pixel images, and the XL, the 1K, the models you're getting out of that, they have a lot more information. They produce a lot better photorealistic images. You can extend the model by another thing called a LoRa, and what that is you're taking a base model and then you're adding more trained data for a particular thing onto it. So if you like a base model, how it's looking, but let's say you're going to build an actual, I don't know, let's say you're making a movie about another Pirates of the Caribbean movie, and you want a model trained on like old ships and stuff. You could get tons of images of like pirate ships and that kind of stuff, and train a LoRa on that, and then the model now has a much better understanding of pirate ships, and that could be for like anything you're trying to do. And there's tons of videos on YouTube for how to do stuff like training base models and LoRa's and stuff. Yeah, the whole system I found to be gives you a lot of freedom to work on a lot of stuff, and this is very much like compositing. I find, like, if you're a compositor, I think you'll find that moving to a system like this with nodes, you're going to find it very easy. The only things you really gotta think about is these latent images. You're no longer working with pixels. Well, you are sometimes. Like, you do have rudimentary features of compositing and layering images, and you generally want to be doing that with your source images and channels. Like, if you're unpacking an RGB thing for getting a certain channel, you can do stuff like that with this system. But eventually you're working in latent space, and you're running things through these K samplers, which is like feeding it into the model and generating an image and decoding it out to an image. So that's all I got. Let me know if I had any mistakes in this. There was a lot of information, and I'm very new to all this stuff, and there's probably a bunch of corrections. And another thing is, if you are quite experienced with ComfyUI and you know how to chain multiple conditions together, tell me how to do it or set up a workspace. It'd be great, and I'll link to it, because it'd be really good to be able to take like an base image like this and be able to control many things at once and have them all running through a single K sampler, and then up-resing it at the end instead of running through like 10 K samplers. It'd be a great way to go through that. All right, I'll talk to you guys later.